Hey guys, I'm Dahlia. Welcome to the Decent Innovation Gyms YouTube channel. Today I'm going to teach you guys how to create an easy, simple whack-a-mole using an Arduino Uno. So let's check it out. Now, due to the coronavirus situation that we're in right now, I won't be using a physical Arduino Uno. I'll be using TinkerCAD. TinkerCAD is a great tool for you to use if you want to design and test circuits virtually. Not only does it have a lot of components that you can use, but you can also code it right on the platform. If you do want to make this project in real life once the dig opens up or at home, you can definitely follow along to this tutorial. I'll leave the components list that you need in the down bar below. So the first thing that we'll do is go into TinkerCAD. So we're going to go up here, look up TinkerCAD.com, and we're going to log in or create an account. Now, I already have an account, so I'm going to sign in, and I'll have it under the Autodesk accounts, but if you don't have an account, I would recommend to pause the video right now to make one and log in. Now that we're in our dashboard in TinkerCAD, you'll notice that there are multiple tabs to choose from. We have 3D design, circuits, code blocks, and lessons. To make our whack-a-mole, we're going to choose the circuits tab. If you have a new account, it might ask you if you want to go through a small tutorial for circuits, but I've had this account for a while, as you can see, so it won't ask me anything. You are welcome to stop the video right now to complete that, but otherwise, we'll jump right into creating a new circuit. As you can see, we start off with a blank screen and a tab with a lot of circuit components such as resistors and LEDs. So the first thing that we'll do is pull out a breadboard, and we're going to pull out this breadboard small. This is because we don't really need that much space since we're only going to be using 4 LEDs, 4 buttons, and 4 resistors. Once we have our breadboard on, we're going to grab some LEDs. So we're going to start on row 2I, and we're going to leave 4 columns of space in between each LED. This is because our button will go right here, and that way we know which button goes with it, which LED. So we're going to keep putting these LEDs in there, and once we have them here, I'm going to color each LED. So whenever you click on an LED, this name and color thing comes up. So I'm going to change the color for this one to be blue, this one is going to be green, this one is going to be yellow. Once we have all our LEDs set down, we're going to start putting in the push buttons. So here we're going to put it one column to the right of the LED. So just like this, and the reason for this is going to be because when we code it, it won't necessarily be that the LED is controlled by the push button, because it's something that is inputted, and yes, when you push the button it should turn off, but it won't turn on by the push button. So we're gonna have these that will be wired up separately. Another thing that we'll add now is going to be some resistors. Now these won't be necessarily connected to the LEDs, though you definitely can if you want. These will be going into ground, and these will be some pull down resistors. I'll explain more on what that means later, but for now, let's just set these down so that they're ready to go whenever we need them. Now that we have our circuit up, or at least the component part of it, we can start wiring it up by pulling out an Arduino Uno. So we're going to look up Arduino, and we're going to put it to the left of our circuit. So before we start wiring up our circuit, I wanted to explain a little bit about how the Arduino works. So we have these digital pins, and the digital pins are what send out the signal from the Arduino into our components to tell them what to do. So like the LEDs, it will tell them if they have to be on or off, or it tells the Arduino what that component is doing. So if I push the button, it'll tell the Arduino if it's being pushed or not. Another thing that we'll use is the power strip. So the power strip sends either a 5 or 3.3 volt power surge into our components, or we can ground our components here on the GND. So all of the negative sides are what is going to be grounded in this case. Now that we have that out of the way, we're going to start wiring up our LEDs. So LEDs have a polarity, so it has a positive and a negative. Our positive will be our anode, or the longer leg if you have real LEDs with you, and our negative is going to be the cathode. So our anode, or the positive side, is going to be connected to our pins. So I'm going to connect this one into the pin number 2. Every time you click the wire, it will bend so that it's all nice like mine. So that's a good tip for you guys to have if you're trying to make your circuit very clean. And just like the LEDs, if you click on the wire, you can change the color. Same with the blue one. We're going to pull a wire and we're going to put that into pin 3. We're going to turn this blue. For our green one, same thing. We're going to get this, go to pin 4, strain that up a bit, and same for our yellow LED. Now that we have these out of the way, we have to also ground them. So our cathode is going to be connected over to this side. So let's do this with all of them, and we're going to turn all of the wires black. The reason for this will be just for clarity's sake. That way we know that that is going to be grounded, so we know where all our grounds are. And we are going to pull this down to this negative strip. This is our ground, or at least what will be connected to ground. And yes, I know that they're connected to the pull down resistors. That is what we want. It's the purpose of the pull down resistor, but we'll explain that more when we start wiring up the button. So once we have this here, we're going to grab this and we're going to ground it. I might pull this down a little bit more just for you guys to be able to see it a little bit better. And just like our LEDs, we're going to turn this black so that we know that this is ground. The next thing that we'll do is connect all of our buttons to our Arduino. So buttons are connected in kind of a funky way where they're connected diagonally. So this top left corner is connected to the bottom right corner, and vice versa for the other 2 corners. So we're going to be using the top left to bottom right, and we're going to connect this bottom right to our pins. So let's start out with our red button. It's important for you to remember the colors for each button, because these are going to be like respective to only one LED. So for this one, we'll have it 1, 2, 3, 4 pins away. And we're gonna make it this way so that our wiring is very clean and that we can read it. We are also gonna continue doing that for the rest of them. So same for this blue one, we're gonna go down here, connect it to pin number 8. Same for the green one once I turn this blue. And our yellow one. So as you can see, that this way is very easy for us to read our buttons, as there's no wires that are going over each other. And this is really good whenever you're trying to code it, so that it's easy for you to find which are connected to what pin. The same for the coloring, that way we know which button goes to which pin. Now that we have our pins wired up to our buttons, we are going to connect our button to the pull down resistor. So the pull down resistor creates a very weak ground connection. So whenever the Arduino is trying to read if it's on or off, it'll definitely be off whenever it's not being pushed. So it doesn't not know if it's on or off. The next thing that we'll do once we have the bottom right of our buttons connected to our pull down resistors is connect the top left to our 5 volt. So this will make it so that there are 5 volts flowing through the button whenever we have it on. And again, it makes it easy for the Arduino to read if it's on or off. So now we're going to connect all of our buttons straight into the same pin that we did for this button. Technically, you're not supposed to put in 2 wires in one pin for if you're making it in real life, but put it right next to the pin that is connected to the top right corner of the first button and you should be good. So this is it. This is our final wiring of the circuit. As you can see, it's very clean and easy to read, which is what we want. So now we can start our coding. Now that we have our circuit all completed and ready to go, we'll go up here into code to try to start coding. Now you have multiple choices on how you want to code it. Now I'm going to do some text code, but you can try using block code if you're new to this. I will be explaining what each command means either way. So the coding for a Arduino is very similar to Java and C++, but it has some special commands like pin mode, which tells you if it's going to be an input or an output, and digital write, which tells that component if it's going to be high or low, which is on or off, and digital read, which reads if it is high or low or on and off. So now we're going to erase this code over here and we're going to start writing ours. So this code that they had in our sample was the code to turn on and off the pin mode 13 LED, but we're not going to use it because we have more than one LED. So the first thing that we'll do is go up here and we're going to first declare some integers. So declare integers. The reason for this is so that whenever we are rewiring, we can quickly change the pin without having to change the variables. So the first one will be const, which means constant, int, which is an integer, and we're going to call it red LED so that we know that this is going to be the value for the red LED. And we can see that we have it on pin 2, and then we're going to put a semicolon. We're going to go to the next line, do const int blue LED, and we're going to keep repeating this until we finish all of them. Now that we have our LEDs, we're also going to have to put in our pins for our buttons. So same thing, const int, and we're going to do red button. And this is going to be pin 9. And you keep on repeating this for all of your other colored buttons. Now that we have declared all of our integers, we can start working in the setup loop. Arduino has 2 different areas, so we have the setup and the loop. So in the setup is where we will set our LEDs as outputs or as inputs. So let's write up here, sets LED and button as input or output. So we're gonna use the command pin mode with a capital M, and this is because it matters if you use capitals or not, so make sure to write it the way that I'm writing it. So now we're gonna put in our red LED, and the way that it's set up, it's pin mode, open parentheses, the number for the pin, which a red LED has the value of 2, so this would be an integer, and then we either put output or input, and this one will be output because it will be displaying a light. It won't be controlled by anything other than the Arduino or the button, so it would be an output. We're gonna keep doing this for all of our LEDs, so we're gonna do Once we have our LED set up, we now have to put in our buttons as inputs. That's because us humans are going to push the button, and that's going to tell the LED to turn back off. So this will only be an input. The Arduino cannot control if it's on or off. It will only read. Perfect. Now we have our whole setup up and running. So after this, we're going to go into our void loop. Now that we have our setup completed, we're going to move on into our loop. In our loop, we're going to control whether our outputs are on or off, and we're going to check if our inputs are pushed in or not. So our outputs would be the LEDs, so it will control whether it's on or off, and for our buttons, it will check if we have pushed it or not. So the way that we're going to start it is by finding a way to quote-unquote end the game. We can't really end the game because the void loop is supposed to run infinitely, but we will imagine that maybe it's just the end of the level or something like that for sanity's sake. So basically we're trying to find a way so that after a certain amount of wax it ends. So we're gonna try using a for loop. So for loop. So a for loop has an integer. We're gonna call it I, and we're gonna make it equal to 0. So this is where it's gonna start off at. Now I want it so that it only whacks 30 times. So we're gonna make I be less than 30, and I want it so that I increments once every round or every time it's whacked, so we're gonna make I plus plus, and this will be what will end the game basically. So now that we're inside the for loop, we want to randomly turn on an LED, so randomly turn on an LED. So we're gonna use digital write, right now all of our LEDs are off, so digital write is how we're gonna alter one of our LEDs, and we're gonna use random 2 because the first pin that we have is 2, and we want it to go up to pin 6, so it's gonna be 2, 6. So the random function will choose a number between 2 and 6, and then we're going to have it be high. So high means that the LED will be turned on. The next thing that we want to do is to check if any of the LEDs are on. So the way that we're going to do this is by using a while loop. So it's kind of similar to the for loop, but there's a difference in logic in a way. So while, and so the first LED that we want to read in is our red LED. So digital read LED, red LED, and This is going to read what the LED is, so if it's high or low, and we're going to check if it's equal to high. Now, the red LED isn't the only one we want to check, so we're going to do this for the rest of the LEDs. Now that we have our while loop completed, we are going to see what we put inside. So for the next part, once we have checked that one of the LEDs is on, we're going to go into the while loop and we're going to check which specific LED is actually on. So for this we're going to use if statements. So if digital read, we're going to check the red LED first, is equal to high. So this checks if the red LED is on, and after this we want to check if our button is being pressed. So check if button is pressed. So for this we're going to use another if statement. So if digital read red button is going to be equal to high, then we're going to turn on the LED. So here we're going to do turns on LED. For this we're going to use once again digital right. We're going to turn off the LED, sorry. Digital right, and we're going to do red LED low. Now all of these steps you will repeat for the rest of your LEDs, so I'm going to speed through it and just copy and paste my code and change the color name. One thing whenever you're copying and pasting code is to make sure that your brackets are lining up correctly, because if they're off in some way, it will affect your code because it won't be in or out of a loop. So just make sure that you're watching out on your brackets and how they're lining up. This is why we indent, so that we can see which bracket goes to what. Now once we're done with this, we also want to add in a delay. So the delay will act as a buffer so that we can see whenever the next LED is on. So these are in milliseconds. So whenever you're writing it, it's 200 milliseconds, not 200 seconds. After this, we're going to get out of our for loop, so that should be this bracket. And we're going to write a simple code that shows that you've ended the game or you've passed the level. So we're going to put shows the end of the game. And for this, loops are always your friend. So for loop is what we'll use again, and I equals 0. And I want this one to only repeat 3 times, so I is less than 3. And then, same as before, I plus plus. So in this loop, we will make sure that this pattern that I'm about to do repeats. So to show the end of my game, I kind of wanted to do something fun, so I wanted all the LEDs to blink on and off 3 times, and that kind of tells the player that the game is over or that they've passed a level. So we're going to do digital right. And we're going to keep repeating this for all of our LEDs. Now we will add a delay in between it, just like before, so delay, and this one's going to be a bit bigger, so 250 milliseconds. And then we're going to repeat the same pattern here, where it's on, but now we're going to turn all of them off, so I'm just going to copy this and change this to low. And finally, we're going to add one more delay so that it doesn't immediately turn on and off. So delay 250. And there it is. This is our little whack-a-mole. And now we can test it out. So if you do end up having any errors in your code, I would recommend that you check that you put semicolons at the end of any command. The loops do not require a semicolon, as you can see, so just make sure that when you're writing it that you put semicolons in all of them. Initially I forgot to put one after the delay on this one, but I corrected it. So just make sure to check that you have semicolons on all of your commands, but not on the loops. If you want to see the original design and code, I will link it down below. If you like the video, please hit the like button and subscribe to see more videos by other staff members from the dig. Have a good day! Bye!